Am I audible? Okay, in the last class, we have discussed about the Fourier transform. In the Fourier transform, we have discussed many properties. Linearity property, shifting property, change of scale property, modulation property, very important, convolution theorem and Parseval's identity. So based on this, today we will discuss few problems in this topic. The last class I have given few problems to work out that. And then you have to remember a few important formulas. Fourier transform pairs. Fourier transform pairs. Find the Fourier transform of write the problem. Find the Fourier transform of the function f of x defined by f of x equal to 1 minus x square if mod x less than 1, 0 if mod x greater than 1. Hence prove that integral over 0 to infinity sin s minus s cos s by s square s cube cos s by 2 ds that is equal to 3 pi by 16. So, problem. Find the Fourier transform of the function f of x defined by f of x equal to 1 minus x square if mod x less than 1, 0 if mod x greater than 1. Hence prove that 0 to infinity sin s minus s cos by s cube cos s by 2 ds equal to 3 pi by 16. Write the solution for this. The Fourier transform of the function f of x that is denoted by f of x 1 by root 2 pi minus v2 plus infinity e power isx f of x dx. Here x is defined in the interval of mod x less than 1. The last class I told that when mod x less than 1, what is the limit? Minus 1 less than or equal to x less than or equal to 1. You consider one real line. The real line, if it is a minus infinity to plus infinity, you can split into minus infinity to minus 1, minus 1 to plus 1, 1 to infinity. In that minus 1 to plus 1 only, f of x is 1 minus x square. This interval f of x is 0. In this interval f of x is 0. Therefore, this interval is actually in the beginning I have given one important property. F of x is the piecewise continuous function. That means piecewise continuous means the interval can be divided into a finite number of subintervals. So here we can write that f of x equal to 1 by root 2 pi 1 by root 2 pi. That minus infinity plus infinity can be divided into minus infinity minus 1, minus 1 to plus 1, 1 to infinity. Actually, this two interval f of x is 0. Therefore, the two interval is 0. You can write this as 1 by root 2 pi minus 1 to plus 1 f of x. So, what is the formula here? E power isx f of x dx. E power isx f of x is what? 1 minus x square dx. So, what is e power isx formula? Cos sx plus I sin sx. Substitute here, you will get that 1 by root 2 pi minus 1 to plus 1 cos sx. So, we can write that 1 minus x square cos sx plus I sin sx dx. In the interval of minus 1 to plus 1, actually you can see here this is 1 minus x square is even function, because if you are substituting that x is minus x, you will get that 1 minus of minus x whole square. That is once again 1 minus x square. Therefore, it is a even function. You know it is the even function. It is the odd function. So therefore, we can write this integral as 1 by root 2 pi integral over minus 1 to plus 1 1 minus x square 1 minus x square cos x dx. The remaining is plus 1 by root 2 pi minus into plus infinity 1 minus x square I sin sx dx. So I take it outside. I by root 2 pi not minus into plus infinity minus 1 to plus 1 sin sx dx. Therefore, this function here, even function, this function is the odd function. The interval of minus 1 to plus 1, that one is 0. So therefore, we can write this as 1 by root 2 pi 1 by root 2 pi. It is a even function, na? It is a even function. Therefore, we can write this as, you convert this interval into 0 to 1 and then multiple with 2 here. So 2 by root 2 pi integral over 0 to 1 minus x square cos x dx. Now we have to use the Ternalis formula here. What is the Ternalis formula? Integral over u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. That is a Ternalis formula. So here what is u, what is v? U is 1 minus x square. This is dv. If you are taking that u equal to 1 minus x square cos sx dx, that is dv. So u dash is minus 2x, u double dash is minus 2, v is sin sx by s, v1 is minus cos sx by s square, v2 is minus sin sx by s cube. Substitute in Bernoulli's formula. This value substitute in Bernoulli's formula, we will get that root 2 by pi integral of 0 to 1 uv u is 1 minus x square. No need to write integral. Put the bracket 1 minus x square. 1 minus x square integral v is sin sx by s. Sin sx by s. And then minus u dash v1 minus u dash. U dash is minus 2x. V1 is minus cos x by s square. And then u double dash plus u double dash. U double dash is minus 2. V1 u double dash v2. V2 is minus sin x by s cube from 0 to 1. See, in 0 to 1, if you are substituting 1 here, 1 minus 1, 0. If you are substituting 0 here, this term is 0. Therefore, root 2 by pi, both upper limit and lower limit, this is 0 limit. Then, all the values in lower limit, that is equal to 0, because it is sin is 0. When you are substituting 0 here, that is 0. Here also sin is 0. Therefore, all the three terms are 0 when it is a lower limit. Only upper limit apply only to the two terms. So how can we apply that? Minus. We have to substitute 1 na 2 cos s by s square. Cos s by s square. And then minus plus here plus 2 sin s by s cube. Sin s by s cube. So what is the next step? Root 2 by pi root 2 by pi 0 first leave it, take it 2 also outside. 2 into root 2 by pi sin s by s cube minus x is there now, you have to substitute 1 here. So cos s by s square cos s by s square. So 2 root 2 by pi taking LCM s cube sin s minus s cos s by s cube. This is the Fourier transform of f of x, that means f of s. That is the one part of the problem. What we have to prove? The integral over 0 to infinity sin s minus s cos by s cube cos s by 2 ds equal to 3 pi by 6. By inversion formula, so what is inversion formula? Fourier inversion formula. What is Fourier inversion formula? What is Fourier inversion formula? Given the Fourier transform pairs, is
One
it not? Uh, Fourier inversion
1 by
formula.
root 2 pi
Hmm.
integral minus infinity to plus infinity e power ist f of t dt.
Inversion formula is f of x equal to 1 by root 2 pi minus into plus infinity e power minus isx you have to write. E power minus isx. There are two, that is Fourier integral formula is different. I'm not asking about Fourier integral formula. Fourier inversion formula. Actually, I have given the two formula for pair. One is Fourier transform. One more is inverse Fourier transform. These two formulas are known as the Fourier transform pairs. Okay. Now you have to write that inversion formula by write down by inversion formula f of x equal to 1 by root 2 pi minus into plus infinity e power minus isx f of s ds e power minus isx f of x dx. But what is f of x here? 1 minus x square. 1 minus x square is f of x, that is equal to 1 by root 2 pi 1 by root 2 pi minus infinity to plus infinity minus infinity to plus infinity e power minus isx is cos sx minus I sin sx. What is f of s? F of s is here 2 root 2 by pi. Whatever the result we have got at the end of the Fourier transform, that is called the Fourier transform of the function f of x, that is called the f of s. So in the place you have to substitute f of s here. 2 root 2 by pi 2 root 2 by pi sin s minus s cos s by s cube ds. We know that cos sx is even function, sin xx is odd function. But very simple question I am asking that whether that f of s is even or odd. Find that it is even function or odd function. Sin s minus s cos by s cube is there, na? Sin s minus s cos by s cube. It is even function or odd function. Anybody? Hmm? Sin s minus s cos s by s cube. It is f of s. To find whether it is a even function or odd function, substituting s equal to minus s. So f of minus s is sin of minus s minus minus s cos of minus s by minus s cube. Sin of minus s is minus sinus cos of minus theta minus minus plus s cos s by minus is there minus s cube. So this minus s cube. So cancel that minus minus here. So that means you take it that minus outside and then cancel that minus here. Sinus minus s cos s by s cube. Once again you got that f of s here. It is a even function or odd function. It is a even function or odd function. Am I audible?
Sir, even
Even function. It is a even function. So we can say that, listen, it is a even function, it is a odd function. The whole thing is that even function. Therefore, we can write that as 1 minus x square, 1 minus x square, 1 by root 2 pi, 1 by root 2 pi, minus into plus infinity, minus into plus infinity, cos sx, cos sx, sinus minus s cos s, sinus minus s cos s by s cube into ds. Remaining minus is there, minus I, 1 by root 2 pi, and then if you are taking that here 2 by root 2 pi also is there. So we have to take it that 2 by root 2 pi. That is also we have to multiple. Actually, I missed that 2 by root 2 pi here. 2 root 2 by pi. Multiple that. 2 root 2 by pi is there. I missed that. So 1 by root 2 pi. Here also we have to write 2 root 2 by pi. 1 by root 2 by minus into plus infinity sinus x sinus minus s cos s by s cube ds. Now, it is whole thing is that even function. Is the even function. Is the odd function. Therefore, the second term is 0. Therefore, the second term is 0. Only the first term will come. But here you have to change that the limit minus into plus infinity. Then I have to change it to 0 to infinity multiple with 2 here. So root 2 get cancelled. Root 2 get cancelled. 2 by root pi multiplication is pi. So 2 by pi and then multiple with 2, 0 to infinity. What is right hand side? 1 minus x square to 0 to infinity cos sx sin s minus s cos s by s cube ds. But we need that s by 2 na, s by 2. Is it not? Sin s minus s cos by s cube ds cos s by 2 we need. So when we get that cos s by 2 here, if you are substituting x equal to 1 by 2, x equal to 1 by 2, we will get that cos s by 2 there. Therefore, 1 minus 1 by 2 whole square equal to 4 by pi integral over 0 to infinity sinus minus s cos s sinus minus s cos by s cube cos s by 2 ds. Now, what is remaining here? 1 minus 1 by 4, na? 1 by 4 that is equal to 4 by 5. Integral over 0 to infinity sinus minus s cos s by s cube cos s by 2 ds. So 1 minus 1 by 4 is 3 by 4. 3 by 4. Cross multiply this pi. Cross multiply this 4 into 4, 16. So 3 pi by 16 equal to integral over 0 to infinity sin s minus s cos s by s cube cos s by 2 ds. So which is the required result? Is the required result. So in the problem, Fourier transform of the function as asked. And one more, hence prove that also asked. So hence prove that means you have to use the inversion formula. eh, Finding the value of the second one. Find the Fourier transform of the function f of x equal to a minus mod x, where mod x less than b, 0 otherwise, or mod x greater than b. Hence it deduces that integral over 0 to infinity sin t by t whole square dt equal to pi by 2. The Fourier transform of the function is given by f of x equal to 1 by root 2 pi integral minus plus infinity e power isx f of x dx. Here, what is f of x? That is equal to, as I mentioned in the last problem, In case if it is a mod x less than a means that meaning is minus a less than x less than a. So take the limit only for minus a to plus a. Minus a to plus a. A minus mod x is f of x. E power isx dx. Yeah, f of x is a minus mod x, na? A minus mod x. If you are substituting that x equal to minus x here, f of minus x equal to a minus mod of minus x. Once again, you will get that a minus mod x. So this a minus mod x is an even function. Therefore, the Fourier transform 1 by root 2 pi minus a2 plus a, the strip can be written as a minus mod x, that e power isx is cos sx plus I sin sx dx. It is a even function, but sin x is the odd function, and it is in the multiplication. It is also the even function. We know that even function into even function is even into odd is odd. Therefore, the second term will not be appear. That will be 0. Only first term will be there. 1 by root 2 pi. And then one more thing, you can multiply with 2 here. You change the limit to 0 to a. And in the 0 to a, positive na, minus is not possible. So always mod x is x. You should know one rule. Mod x tends to x when x is greater than a. Mod x tends to minus x when x is less than a. But here mod x tends to x because x is greater than 0. So a minus x cos sx dx. Using the Bernoulli's formula here, we can integrate that to root 2 by pi a minus x sin sx by s minus a minus x is minus 1, sin sx is minus cos sx from 0 to not 1, 0 to a. Here, if you are substituting a here, that is 0. If you are substituting 0 here, this is 0. So first term is 0 for upper limit and lower limit. And then one more thing, minus 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 is there, 3 minus is there. So take it that minus outside. Minus root 2 by pi minus root 2 by pi cos SA by S cos SA minus, if you are substituting 0 there, cos 0 is 1, cos SA by 1 by S square. and then minus is there outside. Multiple here, we will get that root 2 by pi 1 minus cos SA by S square. Which one is the Fourier transform of the function? Minus cos SA by S square is a Fourier transform of the function. But we have to prove that 0 to infinity sin t by t whole square dt equal to pi by 2. That is one more proof is there. That is half of the problem as done. We have to use the inversion formula. By inversion formula, by inversion formula, what is inversion formula here? F of x equal to 1 by root 2 pi minus into plus infinity e power minus isx f of s dx. One by root 2 pi minus into plus infinity e power isx is cos sx minus I sin sx f of s is here root 2 by pi root 2 by pi 1 minus cos sa by s square dx. Therefore, take it that root 2 by pi outside, that root 2 get cancel, root by is pi. So 1 by pi 1 minus cos s by s square is even function or odd function? 1 minus cos s by s square is even function or odd function? Can you check that? 1 minus cos sa by s square is even or odd? Substituting s equal to minus s there. Huh?
Even function.
Even function. So it is a even function. So it is a even function. It is the odd function, but it is the even function. Therefore, when you multiply with that odd into even, that will be odd. The integral of minus into plus infinity, that is equal to 0. Therefore, only even function will be occur, odd function will come. So 1 by root 2 pi, 1 by pi, multiple with 2 here, integral over 0 to infinity cos s cos sx 1 minus cos s by s square dx. But what is right hand side? Right hand side is f of x. What is f of x here? A minus x, because in the 0 to infinity is the limit a minus x will become. But we need only that sin square t by t, na? Sin t by t whole square. Therefore, that cos sx will not come. If you are substituting x equal to 0 on both sides, cos s, no, cos sa, not only cos s, cos sa. X equal to 0 on both sides. both sides, we will get that a equal to 1 by pi, and then multiple with 2 here, 2 by pi, 0 to pi, sorry, not 0 to pi, 0 to infinity. If you are substituting x equal to 0 here, it is 1. So 1 minus cos SA by s square ds. If you are substituting that, what is 1 minus cos SA? You know the value of 1 minus cos SA? 1 minus cos SA formula. Uh, okay, fine. Cos 2 theta is cos 2 theta is 1 minus 2 sin square theta. Using this formula, you get that cos theta equal to cos theta equal to 1 minus sin square theta by 2. So 1 minus cos theta equal to 2 now here 2. 1 minus cos theta equal to 2 sin square theta by 2. 2 sin square theta by 2. Using this formula, 1 minus cos SA is 2 sin square SA by 2. 2 sin square SA by 2. So we can write this as 2 by pi integral or 0 to infinity 2 sin square SA by 2 divided by s square ds. Now, substituting that SA by 2 is t, because we need that sin t by t square. Na? Substituting SA by 2 is t. So, A ds by 2 is dt. Therefore, dt equal to dt, sorry, ds equal to 2 dt by a. 2 dt by a. If SA by 2 is t, then S equal to 2t by a. 2t by a. Substitute all the value here. What you get? A is there in the left hand side. Right hand side is 2 by pi. Integral or 0 to infinity, inside one more 2 is there. So 4 by pi, 0 to infinity, sin square t by s square. Na? What is s square there? S is 2t by a. S square is 4t square by a square. And then ds is there. What is ds here? 2 dt by a. 2 dt by a. So take it that a square to the numerator, and then this a get cancelled. If you cross multiply here, a square will come, that a square will get cancelled, and then this 4 get cancelled. This 2 is there, therefore cross multiple that 5 by 2 equal to integral or 0 to infinity sine square t by t square, na? That can be written as sine t by t whole square dt. Hence, proved. Hence, proved. Okay.